More than 40 years ago, humanity launched a machine that would travel farther than anyone imagined possible. In 1977, Voyager 1 left Earth carrying cameras, scientific instruments, and perhaps its most famous cargo, the Golden Record, a collection of music, greetings, sounds, and images representing life on our planet. Its mission was expected to last only a few years. Instead, Voyager 1 became the first spacecraft in history to leave the protective bubble created by the Sun and enter interstellar space, continuing a journey that has now stretched across billions of kilometers. Even today, every signal it sends begins a journey lasting more than 22 hours before reaching Earth. Communicating across such an enormous distance is one of the greatest engineering achievements ever attempted. Yet in late 2023, mission controllers encountered an unexpected problem. Voyager 1 was still receiving commands and continuing its mission, but the engineering information returning to Earth suddenly stopped making sense. Instead of meaningful telemetry, the spacecraft transmitted data that appeared corrupted. Without accurate engineering information, NASA could no longer determine the health of many onboard systems. After decades of flawless performance, many wondered whether Voyager had finally reached the end of its extraordinary mission. The challenge facing engineers was unlike almost anything encountered before. Every instruction sent toward Voyager required nearly a full day simply to arrive. If a command failed, another day would pass before the response returned. Troubleshooting a computer located beyond the planets demanded extraordinary patience. After weeks of investigation, engineers discovered that a portion of memory inside Voyager's flight data system was no longer functioning correctly. Rather than giving up on the aging spacecraft, they developed an ingenious solution. Critical software was carefully relocated into healthy sections of memory, allowing Voyager to resume sending understandable engineering data back to Earth. The repair demonstrated something remarkable. A spacecraft designed with 1970s technology had successfully received a software repair while traveling through interstellar space. Few people imagined such a feat would ever be possible. News of the malfunction quickly spread across the internet, inspiring countless dramatic theories. Some claimed Voyager had intercepted mysterious transmissions. Others suggested it had discovered something hidden beyond the solar system. In reality, none of those claims were supported by evidence. The true story was already extraordinary enough. It showed that human ingenuity could solve problems across distances so vast that radio signals require almost an entire day to travel one way. Still, the event raises an interesting scientific question. If humanity ever did receive an unusual signal from deep space, how would we know whether it came from nature or something artificial? Astronomy has repeatedly shown that the universe produces astonishing phenomena. Pulsars once seemed impossible. Gravitational waves remained theoretical for a century before being detected. Even planets orbiting distant stars were unknown until recent decades. Each discovery reminded us that nature often appears mysterious until science uncovers the explanation. As Voyager 1 continues drifting farther into interstellar space, it carries more than scientific instruments. It carries a reminder of humanity's curiosity. Long after its power finally fades, the spacecraft will continue silently crossing the Milky Way for millions of years, becoming a tiny ambassador from a small blue world that dared to explore beyond the edge of its own solar system. After Voyager 1 reminds us how vast our own cosmic neighborhood truly is, another remarkable observatory is looking even farther, billions of light years beyond the edge of our galaxy. That observatory is the James Webb Space Telescope. Unlike Voyager, which travels through space, Webb explores the universe by collecting some of the oldest light ever emitted. Every faint photon reaching its golden mirrors has traveled across billions of years, carrying information from a time when the universe itself was still young. In many ways, Webb is not simply looking farther into space. It is looking backward through time. One of its most extraordinary tools is infrared vision. As the universe expands, light from distant galaxies stretches into longer wavelengths, becoming invisible to ordinary telescopes. Webb was specifically designed to detect this ancient infrared light, allowing astronomers to observe galaxies that formed only a few 100 million years after the Big Bang. Among its most exciting discoveries are extremely distant galaxies whose stars began forming during the universe's earliest chapters. Some of these ancient systems contain surprisingly old star clusters known as globular clusters. Today, globular clusters orbit galaxies like the Milky Way and contain hundreds of thousands of stars packed tightly together. Because many of these stars formed at nearly the same time, globular clusters serve as natural records of the early universe. Finding similar systems around galaxies billions of light-years away helps astronomers understand how the first generations of stars assembled into mature galaxies. But observing such distant objects would normally be impossible. Nature provides an extraordinary solution. Between Earth and many remote galaxies lie enormous galaxy clusters whose gravity bends the fabric of space itself. This phenomenon, predicted by Albert Einstein's theory of general relativity, is called gravitational lensing. Like a giant natural magnifying glass, the immense gravity of these clusters bends and amplifies light from galaxies located far behind them. Without this effect, many of the faint galaxies now visible to Webb would remain hidden forever. By combining Webb's powerful infrared observations with detailed gravitational lens models, astronomers can reconstruct the appearance of galaxies that existed when the universe was only a small fraction of its current age. Each observation helps answer profound questions. How quickly did the first stars form? When did the earliest galaxies become organized? How did the building blocks of modern galaxies emerge from the darkness following the Big Bang? Every discovery improves computer simulations and challenges existing theories of cosmic evolution. Future observatories will continue expanding this remarkable journey. NASA's Nancy Grace Roman Space Telescope will survey enormous regions of the sky, discovering thousands of additional gravitational lenses. Meanwhile, the Vera C. Rubin Observatory will repeatedly map the southern sky, revealing countless new galaxies and helping astronomers identify targets for Webb to study in even greater detail. Together, these observatories will create the most comprehensive view of the universe ever assembled. What makes these discoveries truly extraordinary is not simply their distance. It is their age. Every ancient galaxy observed by Webb is a message from a time before the Sun, before Earth, and before life itself existed. Each one is a surviving chapter from the earliest history of the cosmos. The deeper we look into space, the further we travel into time. And with every observation, humanity moves one step closer to answering one of its oldest questions. How did everything we see today begin? The story is far from complete. But thanks to telescopes like James Webb, we are finally beginning to read the universe's oldest pages, one galaxy, one star cluster, and one beam of ancient light at a time.